All right, so next up we got Scott, who's a developer avocado for for Microsoft. What do you actually do? Oh, right, he will actually explain to us. Because I always just see you guys being, doing cool shit. Like, anyway, Scott's going to talk about FAS, which is Ferraris as a service.
Yeah.
Yeah, cool. I think. I guess we're going to find out. So remember, this is serverless days. So we have a serverless stuff. Yeah, got good. Okay,
Yeah.
cool.
And I'm going to talk about Kubernetes.
All right, please welcome Scott.
So I just start a little bit about myself because that was what came up. I work for Microsoft. I'm a developer advocate. I work on open source. I'm predominantly work on Kubernetes. That's on AKS and also upstream. So I'm part of the Kubernetes working group for policy, which is security, and a few other bits and pieces on Kubernetes. I'm write everything in Golang. I've worked for a long time on container-related stuff like Containerd and a whole heap of other bits and pieces around containers. And I'm in CNCF ambassadors and a Docker captain. So I've been around the container ecosystem for a long time. And I was like, well, let's have a look at all this serverless stuff. So this is like kind of me going backwards from containers to serverless. So this might be a little bit different. The other thing that I work on is service mesh. So I'm heaps like into low-level stuff like Linux kernels and networking and stuff in the kernel. But then I'm also into distributed computing as well. So yeah, at Microsoft, I mostly work on Kubernetes-related stuff. So some of the stuff that has come up is like, why would you want to run functions as a service on top of Kubernetes? It's kind of been covered a little bit today. There's a few other bits and pieces I've seen with customers that I'll talk about. And then I'll look at three of my favorite ones, which is Knative, OpenFast, and Keter. And I'll do some pros and cons on all of them as well, because some are like super complex and some are super simple. So it depends on what you want to do. But why would you want to run serverless on top of Kubernetes? There's a whole heap of customers out there that may not use a public cloud. And there's a whole heap of like industries out there that don't use it. Flexibility of language, as I spoke about before, I use Golang and Rust. I don't think there's a lot of serverless functions out there on cloud that support Rust. So therefore, like I might have a team that needs to write stuff in flexibility of language. Portability we've spoken about already today, but another one is compliance and security. In another lifetime before I joined Microsoft, I worked in Australian Health. I built a container as a service platform for Australian Health, took it through the compliance and whatnot. And things like Lambda weren't certified for ISM. So like I couldn't use Lambda even if I wanted to, but if I wanted to use function as a service, I would be able to use like Kubernetes and spin it up myself and get the same sort of like flexibility. So that's a really important one when talking about it is to customers that I see, is that there is a compliance and security regulation where things like Lambda and Azure functions aren't signed off by a governing body, but they still want the flexibility of function as a service. So I speak to a lot of people about that. I may get into a lot of those conversations because I do security stuff around Kubernetes as well. But this is how a portable serverless is defined by CNCF. So basically, there's a controller of some sort. So that could be Knative, Keter, or OpenFast. There's an event source, and there's a function instance. I won't spend a lot of time doing this because there's been a couple of other talks today that have been similar. Here's another one. You can see it, code, deploy. There's some sort of artifact image, which is usually a container, and deploy to the function instance, and there's monitor and scaling. So let's have a look at Knative. Knative I really like. It's taken a lot of things that Kubernetes does natively and applies it to function as a service. So even if you look at the architecture of Knative, it's very similar to the architecture of Kubernetes itself. It has a control plane. It has, like, it's fully extensible, so you can do a whole heap of stuff with it. The problem, as with Knative, as with Kubernetes, is it's fully extensible, and you can do a whole heap of stuff with it, so that you can give yourself enough rope to hang yourself if you don't know what you're doing, which can be quite dangerous. Knative is the most complex out of all of the function as a service on top of Kubernetes, and I'll get into that, the pros and cons. So why did they come up with Knative? One of the flaws with Kubernetes, as we've spoken about earlier today, is you can't scale to zero. The service API type just won't allow you to do it. Routing goes all chaos, and you need a library there to tell services that there's no pods underneath it. So Knative looks at that. It also allows you to do a whole heap of stuff around service mesh and roll back and roll forward of your functions, which is super important. The only thing that's the downside of that is that it's highly dependent on a service mesh. And depending on how confident you are with like Kubernetes 1, service mesh 2, and then functions 3, this can be quite complex. Myself, like I think Knative is really good, but just be buyer beware because there is a lot of abstraction on the stack there, and therefore it can get you in trouble. Especially, how many people here know Istio? How many people here would say that they know Istio really well, that they can debug it? Yeah. Knative has a dependency on Istio pretty much, depending if you, or the Ambassador now, but it's usually Istio. Even if you use Glue, it's using Istio. I love Istio, don't get me wrong. But if I've been in the situations with customers where I'm actually like execing into a sidecar pod on Envoy and doing TCP dump to find out what's gone wrong with an Istio deployment. So unless you understand the networking stack down that low, it's complexity that you might not need. And this is what the stack looks like. Again, as I mentioned, you've got Kubernetes as the bottom. That's your event source. You can then plug other event sources on top of it. You have Knative, which is another control plane that sits there, and you have Istio on top. And yeah, so there's 3 levels of complexity there that you need to deal with. And yeah, I just want to be like upfront when running it. I've worked on Kubernetes now for years. Istio I've been across for about 2 years, and Knative since it come out. And yeah, there's a lot of knowledge you need to have there to be able to run this in production and say have a 99.9% SLA on your production services. Knative comes in in 3 different parts. Now, some of these parts have been broken out, so you can replace them. Before, when Knative first came out, you needed all of it. Now you can just install what you need. Knative has a build system that allows you to build containers inside Kubernetes. You may or may not need this. Serving is serving, and eventing is the event source listening, so we'll go through it. So Knative build is actually really cool. So it allows you to build OCI images on top of Kubernetes. So the storage inputs can come from like Git, it can come from anywhere you want. Google Cloud Storage. This is highly sponsored by Google, so you'll see a lot of integrations with Google Cloud, some with AWS and some with Azure. But as I said, I work on the OSS side of Microsoft, so we look at all of this stuff. But this is really interesting, like you can build OCI images and things like that and deploy your functions. Now, this may or may not be the right way to do it. You might want to put your functions through some sort of testing process and not deploy them live on a cluster. You might have a CD process and bits and pieces like that. So you may need build or you may not. That's totally up to you. As I said, this is pluggable. And as you can see, it uses, like, if you're a Kubernetes native person like I am, this looks like fairly familiar to me. You can see there that it's just a resource type. And there's a new API type being put called build knative.dev, and it's in alpha. And you can see there, you're basically just using a Ubuntu image. And you can put secrets and whatnot in there. One of the things that I don't like as a security person is the line right here, mount path run docs, the Docker socket. So that's basically giving root to your whole host on your build server. So like if you want a Pona box, that's the first way to do it. Because you would literally get into your root on the host end. You can start looking at the whole control plane and stuff like that. So as I said, again, build might be good for you. It might not be. You might want another way to do it. But the option's here, which is good. Knative serving is actually the middleware, and this is where most of the really exciting stuff happens. So it deploys your containers, but it also tracks different versions of them. So if you have a function and you roll it forward, you can then roll it back, depending on the number and things like that. Istio will look after the service mesh side of it for you. So Istio, although it's abstracted from you at this point in Knative, until something goes wrong and then you have to troubleshoot Istio. But in the perfect world, Istio is abstracted. So Istio will do all the service routing, all the mesh will be there. This will look after ScaleToZero for you. So therefore, you don't need to know anything at all. It will just take snapshots of your functions. And when this works all really well, it's just that depending on if you want a black box or not, if you want to understand this all the way down to like the networking layer and bits and pieces like that. One of the things that is a plus if you've got Istio, if you're really into security, you can actually do zero trust functions, and you can actually use Spiffy and Spy if you know what that is, and have signing and zero trust between all your services. And Pilot in Istio will look after the authentication and authorization of functions talking to each other. So if you're in a highly compliant area where this is super important for you, Knative is a really good choice. But that is super hard to set up. It's not easy. Like, don't get me wrong that you install Knative and you get this zero trust out of the box and stuff. There's a lot of configuration that goes into it, and you need to understand what you're doing. But that's there if you need it. I'm just making sure I'm not running out of time. So one of the things that Knative Service does, as you can see there, you've got the service, which is your function. It goes into the route name, so that's Istio there. Then you've got your configuration that gets pulled out of the function itself, and you can see there you got the revision. So you can roll forward and roll back depending on what you need to do, and that's quite simple. And Istio will update the route, and everything's happy because you've got the service mesh there. And Knative eventing, as I spoke about, there's a whole heap of stuff that you can see there. You can see there you can get events from Kubernetes itself. Sorry, I had the flu. I was in bed sick on Monday. So I've been trying not to cough. GitHub, GCP, of course, AWS. A container source can be anything, Cron, Kafka, and Camel. So that's really, really good. And you can see the event in there. It's not too dissimilar to the diagram we showed before. There's an event, there's a receiver, a subscriber, and bits and pieces like that. Deploys the service, and then the service looks like the previous diagram where the service hits Istio, Istio does a route, goes to the container, and all happy days. So these are what I put down as pros and cons. One of the pros is there's clearly defined APIs. It follows the design pattern of what Kubernetes itself does. It goes through the similar processes of upgrading from like alpha, beta, and stuff as Kubernetes, so that's really good. It offers MTLS out of the box because it uses Envoy, which it uses to Istio. It's got decent security out of the box. Service mesh comes out of the box. So I'll put that as a pro, and you can see I've also put it as a con. It depends on Istio. So this depends on who's looking at it, because like if you understand Istio and service mesh, that's like awesome. It installs it out of the box, all ready to go. If it's a black box to you, I would put that on a con side. It is the most complex. It's got the most moving parts. And it works on Kubernetes only. So you can run it up on Minikube and a whole heap of stuff on your laptop. You can run it on client as well if you use client, which is Kubernetes inside Docker, and you can test it locally as well. But yeah, this gives you the most functionality, but it also is the most complex. So if you're running it yourself, you just need to be aware of that. So the next one off the bat is OpenFast. OpenFast is actually is made by a friend of mine, Alex Ellis. He was in the Docker Captains project, and basically he about 3 years ago was looking for an event-based way to run containers, because back then Lambda and also Azure functions were like Python and Node, and again he didn't use those languages, so he was looking for build one on top of Swarm. This one's the easiest one to get up and running. It just literally is a Docker Compose file. You can get it running on your laptop. There's not a whole heap happening to it. There's only a few services. You can install service mesh and stuff on top of it, but you have to do that yourself. As I said, there's just the API gateway. Sorry. This runs on top of containers. It runs Prometheus to look at the metrics. So pretty much everything in the cloud native world has Prometheus metrics. So it will work for most things. It works on Swarm and Kubernetes, or you can run it just locally on Docker itself. The API gateway is what the user hits, gets the function, invocates the function, and the function watchdog watches it and gets the results back. It's one of the most lightweight. Thank you, sir. I didn't want to walk all the way across the projector to get it. as I said, it's the easiest to get up and running. There's Gateway Watchdog. There is another component you can install called ScaleToZero. So this also fixes the issue with Kubernetes where the services, the routing goes a bit weird when there's no pods underneath it. But it's limited on its event platform. So depending on what you're using, you can only use like Kubernetes or Swarm events and Prometheus. So if you're in the cloud native world, and as I said, everything's got Prometheus adapters, that's all good. If you use ASP.NET and stuff like that, it might not be the best fit for your functions because I haven't seen much .NET stuff with Prometheus. The other thing to be wary of, although that they've done a lot of security on the actual container side, so like running as non-root, if you run in Docker itself, you can use user namespaces and stuff like that. The security on the application side isn't quite there yet. So like MTLS, authentication and stuff needs to be spun up by yourself. There's heaps of documentation online how to set it up securely, but you need to go find that documentation and do it yourself. So as I spoke about here, this is OpenFast. This is what it looks like. So you've got the API gateway. As you can see there, just even off their diagram here, it is HTTP 8080. So straight off the bat, you're not even using front-end TLS. Like you can set this stuff up, as I said, but just be mindful of when you deploy this. There's like deploying OpenFast, which you'll get it up and running really quickly. Then if you want to secure it, you need to go through a whole heap of other steps, especially putting authorization on the front end. So if you just deploy it and use like the Helm chart, it'll actually spin up a controller and then a public IP address on your cloud controller on Kubernetes and have an open fast gateway for the internet. So if you want to give free functions to the internet, this is a good way about going about it because it'll be out there and people can use it and they'll probably love you. But I don't know if you want to sponsor that yourself. So yeah, just be mindful of when you spin this up, there's security controls that you need to put in place after you've spun it up. Knative has got a lot of better security out of the box. But as you can see there, there's HTTP between everything as well. So if you need your data encrypted in transit, you can use something like Linkerd or Istio on this to do that and use Envoy proxies and offhand the SSL termination. That'll all work with OpenFast, but again, that's something that's documented that you have to go and do yourself. So there's some complexity on top of it. To get it up and running and then like deploy something on your laptop on this is super quick, but then get in a production ready environment, there's some mucking around you've got to do depending on what you want to do and the security concerns you have. So as I said here, this is the most lightweight. It's the easiest to set up. There's a massive community. There's a whole heap of Raspberry Pi people that absolutely love this project. They've got like 15 Raspberry Pis sitting on their desks with Kubernetes and a whole heap of functions running. So there's like Slack channels and a whole heap of stuff like that on this. So if you actually run into a problem on this project, it's pretty quick to get an answer. It's also pretty quick to get some feedback on a pull request and stuff like that. It's got a fairly good feature set. So like with the stuff from Knative, it assumes that you've already pushed your container to a registry with your function and it can pull it. Yeah, it works fairly well. If you don't use Kubernetes, it supports Swarm as well. It's got a web UI as well. None of the other functions as a service have a web UI. I don't know if that's a good thing or a bad thing. I put it as a pro because like there's the store and stuff. You can download other people's functions that they've already written and stuff. So it's kind of cool. I don't know if you want that in a production environment, but yeah, it seems cool when you got it on your Raspberry Pi and you can find other people's functions and test a whole heap of stuff. And cons is like security needs to be implemented yourself. That is a lot of work. It supports Linkerd, but that is optional. So if you want Envoy or want mutual TLS between your functions and also between the components, that's something that you need to do yourself. And it only works with Prometheus. As I said, I like Prometheus in Cloud Native and Kubernetes world. Prometheus is everywhere. If you're not in that world, though, that might be a bit daunting because there's something else to learn. And now Keter. So Keter come from Microsoft and also from on OpenShift from the Red Hat people. Keter allows like for fine-grained auto-scaling, and it works with the horizontal pod autoscaler, which if you're a Kubernetes person is the controller that looks after scaling things. And I'm going to do a really cool demo that took a conversation I had with the folks at Alibaba Cloud and some work Jeff did, and then combine it all together to do like full automation scaling across and protect your cluster and stuff with functions. But yeah, there's auto-scaling set on rules and set on definitions. I really like Keter because it can run on cloud and edge. It also natively works with Kubernetes out of the box. It's also the most lightweight. It does like one thing and it does it super well. And you can build a whole heap of tooling around it. So as I said, it provides two things. So it acts as an agent for deployment and scales down to zero. So it uses OCRS, I believe, for the library there, which is from Deis Labs. And then it also listens to a metric server inside Kubernetes and then decides what to scale on it. One of the things that we found with Keter straight out of the box is it's really good at scaling horizontal pod autoscale. Actually, this isn't a Keter problem. This is a Kubernetes problem. Let me rephrase that. One of the things that we found with Kubernetes, when you need to scale a horizontal pod autoscaler, if you use a VMS set, even in Azure, or you use an autoscaling group in AWS, it's slow. It's slow compared to a function. So like on Azure, if we want to use VMS and we want a new node in the cluster, it's about 4 to 6 minutes, give or take. When I was speaking to the people at Alibaba Cloud, they were taking 11 million transactions a minute on Black Friday. So so say it took 6 minutes because the site's under load, that's what, 66 million transactions they've lost. And that's transactions per user. That's users actually buying something, so that would be multiple transactions with it. And they were looking at ways to auto-scale Kubernetes outwards. So it's some of the work I'll show you we can use and protect your cluster. So yeah, so when you start to talk about functions, like containers can live for a short time, functions are going to live usually even shorter. So Kubernetes scaling is definitely a problem, and I'll show you how to get around that. So this is basically Keter's architecture. So you've got Kubernetes there. You've got the horizontal pod autoscaler, and you've got Keter itself talking to it. There's a metrics adapter, a controller, and a scaler, and then it scales the pods out where you need to, which is really good. Now, the other thing that Kubernetes struggles with scaling is it's got self-protection in it. So if you start scaling and you've got no more nodes coming up and you've got no more compute resources, you'll have a whole heap of pods saying pending, and it'll just sit there. So we at Microsoft and the other clouds have looked at ways to scale Kubernetes more efficiently. So depending on how you deploy Keter, I'm solely focusing on deploying it on Kubernetes. You saw some people today did the function CLI. I'm just using the CRDs and Helm to install it because I'm a Kubernetes guy. And the thing that solves scaling for functionality is virtual kubelet or virtual node on Azure. So virtual kubelet's available on HashiCloud, HashiCorp Nomad, Azure, AWS Fargate uses it. Pretty much everyone but GCP. And it'll allow you to scale your cluster quickly for the functions, and we'll demo that in a minute. The event source for Keter is quite good. So there's Kafka, RabbitMQ, the Azure storage queues, AWS, and Prometheus. The interface to build new event sources is actually quite simple, so you could actually build your own as well. So we'll go through a quick demo. I'm actually going to kick the demo off. I'm going to show you the code, then we're going to come back. And if the demo gods are good to me, my demo will have worked. So can everyone see that? How do I do this? It's Alt Shift. No. Nope. Okay. So this one's not actually that important. We're just going to install stuff. If you want to know what I'm doing with Porter install -c Keter, there's another project that I'm working on called Cloud Native Application Bundle, and it actually allows you to wrap up containers and functions and deploy them all at once. Talk to me after if you want to know more about that. But we're just installing that. We're going to go across here, and we'll go like that. So that one's actually okay. And then over here, make sure we got that. Okay, cool. We'll go back and I'll explain to you what's that's doing. So RabbitMQ takes a minute to play. This is actually a demo that Jeff did, as I said, on the Keter website, and I've just modified it to work with a few other Kubernetes bits and pieces. So basically what we've done is we're deploying the consumer, which is as you can see there, the image is actually from Jeff Holland, RabbitMQ. But what I've done to change it a little bit is I'm using virtual node and virtual kubelet, which is over there in the red. So in the purple. So what that allows me to do is it allows me to burst all these resources onto ACI away from my cluster. So imagine if I've got a whole heap of functions coming in or customers coming in to purchase something. I don't want to flood my cluster and while the VMS is scaling up, because as I said, that's going to take about 6 minutes. So what I'm actually going to do is I'm going to offhand that load to ACI, and I'm going to use virtual node. And I've set up a virtual network to do it all securely on the back end, and that will allow me to get the scale that I need. And then I'm just going to deploy the scale object. As you can see there, it's using the CRD in Kubernetes. It's the Keter CRD. You can see there all the intervals and stuff. You can see there super good password and stuff like that. But yeah, it's just you can see the cooldown and the ping interval and everything. So that's Keter just looking at the horizontal pod autoscaler, and then the publisher itself. So this is the actual thing doing the work. And hopefully now, if I've done this correctly, no, I've still got a second to go. Hopefully this will work. Okay, cool. It takes a second for RabbitMQ to run. So RabbitMQ is running. So you can see now that RabbitMQ is running, and you can see now that the publisher, which I want it to do, was on the node pool. And you can see all the other functions now running on virtual node. So that's emulating that there's multiple traffic coming from multiple places, and you can see that it's pending and terminating. That's because the function's happening really quickly, and Kubernetes can't keep up with it. But basically what I'm doing is I'm bursting the load across virtual node. This is protecting my cluster from getting hammered. And this is something we worked on with Alibaba Cloud, and they use this on Black Friday, on their Black Friday sale. So as you can see there, you can see the horizontal pod autoscalers coming in. It can see the load. It can see that I've got 0 replicas, 1 replica, and 4 replicas. Now it's going up to 8 replicas. So as you can see there on my Kubernetes cluster, the functions are running, all my services are running like we would, but I'm offhanding that traffic away from my cluster. So this is a super powerful tool to have in your tool belt if you're doing functions on a cloud, and you can use ACI. ACI is on most. For us, ACI anyway, is on the Glove Cloud, and so is the AKS. This would work just as well with AWS Fargate as well. So it's not Azure specific. This is across most cloud providers, as I said, except GCP doesn't use virtual kubelet at the moment. But yeah, so if you're looking at combining like serverless runtimes and then Kubernetes, like one of the things is like just be aware as well of the scalability of it. Because as I mentioned, that Kubernetes does scale slowly if you use VMS or auto-scaling groups. And if you're looking at how quick this worked, I still wouldn't have my new node up yet. But offhanding it straight away to ACI, let me spin it up like that. And that's a separate VM, and there's VM segregation between containers, so you're not using shared resources on the virtual node side either. So it is fairly secure. So back to Keter. So Keter, as I said, it's most lightweight. It works with any service mesh. So if you want to introduce a service mesh, you can. It's just HTTP, gRPC traffic. There's a good amount of event sources. One of the things I like about it, Keter, is it does few things, but it does what it does well. It doesn't try to be too complex. It doesn't try to be too smart. It just does like one job and does it really, really well. And if you come from the Linux background or the Unix background and the Unix philosophy, that's what it is. As you can see, I work for Microsoft, but run Linux on my Surface Book, so I like open source stuff. It uses Kubernetes native constructs. It works out of the box with virtual kubelet, which I just showed. Some of the cons might be it might not have all the bells and whistles that you might want, and it is Kubernetes only. But yeah, I really like Keter. And combining things like, as I said, with virtual kubelet, and you could apply a service mesh to go across. It works really well. And that is how to do serverless on Kubernetes from a Kubernetes guy, not a serverless guy. Any questions?
Hi, thanks for the talk. It was really interesting. I was, with the point about security with running the Knative build using the Docker socket, is there any scope or any movement towards using Builder instead so it doesn't require that?
No, I believe they're moving towards BuildKit.
Okay.
Yeah, so BuildKit and using the non-root inside BuildKit. So yeah, when they move to that, that would be good. At the moment, it's not supported. Yeah. So yeah.
Got one more up here.
You hear a lot of talk about, the Kubernetes over serverless due to latency and stuff requirements and stuff like that. Have you sort of looked into sort of the cold starts on Keter, sort of comparing that to, say, some of the serverless functions out there and kind of what sort of variability, P99s and stuff like that you might expect to experience?
I personally haven't done that, but that demo that I just did then was like pulling from Docker Hub in the US to Australia and spun up on virtual node. So that was all real live done. That's the spin up time, depending on the image. So if this was a production environment, say on Azure, and you wanted it quicker, you could have a geo load balanced internal registry and it'll pull it quicker. But yeah, that was just done on public, pull it down, that's the warm up time. I've seen metrics like that from Alibaba Cloud only because they did that. But I don't know if we've done that yet. I mean, that might, yeah, I'm not sure, I can't answer that. Yeah.
So OpenFast or Keter?
For me?
Yeah.
Well, this is like, first of all, I'll do a disclaimer. This is not Microsoft's opinion. This is my opinion. I personally would go with Keter, only because like I like the Osiris lab. I like the Deis Lab Osiris library. Keter, as I said, is more lightweight. It does everything I need, and there's a whole heap of other stuff in OpenFast that I don't need. So that would be my personal decision. But yeah, I'm not discounting OpenFast. It's not a good project either. But yeah, I like really lightweight, non-fancy stuff.
Cool. All right.
Okay.
Thanks very much, Scott.
Thank you very much, everyone.